2.5-inch SATA SSD. One of the most common questions is, what exactly is a 2.5-inch SATA SSD? The answer is simple. It is a storage drive that uses the same 2.5-inch size as many older laptop hard drives but stores data on flash memory instead of spinning disks. Another common question is whether it is still worth buying today. For many people, the answer is yes. It offers much faster boot times, quicker file transfers, and better reliability than a traditional hard drive, while remaining affordable. People also ask if installation is difficult. In most cases, it is very straightforward because many desktops and older laptops already have a SATA connection. Finally, users often wonder if it is as fast as newer SSDs. While it cannot match the speed of NVMe drives, a SATA SSD is still a huge improvement over hard drives and remains a practical choice for everyday computing, office work, media storage, and gaming. M.2 SATA SSD. At first glance, this drive looks completely different from a traditional SSD. Instead of a metal box with cables, it is a small circuit board that plugs directly into the motherboard. Many people assume that this smaller design automatically means higher speed, but that is not always true. An M.2 SATA SSD still communicates through the SATA interface, so its maximum performance is very similar to a standard 2.5-inch SATA SSD. The real advantage comes from its compact design. It removes the need for extra cables, improves airflow inside the computer case, and saves valuable space, especially in thin laptops and compact desktop systems. Because of its simple installation and clean appearance, many manufacturers adopted it for modern devices. It became a bridge between older SATA technology and newer high-speed storage, giving users a more convenient design while keeping familiar performance and broad compatibility. M.2 NVMe SSD. There is a reason why this tiny drive changed the way modern computers feel. At first, it looks almost identical to an M.2 SATA SSD, making many people think they perform the same. The real difference is hidden inside the communication method. Instead of using the older SATA interface, it connects directly through PCI Express lanes using the NVMe protocol. That small change unlocks dramatically higher speeds for reading and writing data. Suddenly, large files move in seconds, games load much faster, and demanding software feels more responsive. Yet speed alone is not the whole story. Lower latency means the processor can access data with less waiting, improving overall system responsiveness. As software continues to grow more demanding, this technology has become the standard choice for new computers, offering performance levels that older storage technologies simply cannot reach while fitting into an incredibly small physical space. PCIe add-in card, AIC, SSD. Imagine installing a storage drive that looks more like a graphics card than an SSD. That is exactly what a PCIe add-in card SSD does. Instead of using a small slot or connecting through cables, it occupies a PCI Express expansion slot on the motherboard. This design allows engineers to include multiple flash memory chips and advanced controllers, creating storage solutions capable of handling enormous workloads. In high-performance workstations and professional editing systems, every second matters, and these drives are built to keep data flowing at incredible speeds. Some models even include large heatsinks or active cooling because the hardware generates significant heat during heavy use. Although they are uncommon in everyday home computers, PCIe add-in card SSDs demonstrate how storage technology can scale beyond ordinary consumer needs, delivering exceptional performance for professionals who constantly process massive files and demanding applications. U.2 SSD. At first, this drive may seem like an outdated design because it uses a cable instead of plugging directly into the motherboard. Surprisingly, that cable is actually one of its greatest strengths. A U.2 SSD combines the speed of NVMe technology with the flexibility of a removable drive, making it especially valuable in servers and enterprise workstations. Instead of opening the entire computer to replace storage, technicians can often swap drives more easily. Another unexpected benefit is cooling. Because the drive sits away from crowded motherboard components, airflow can be improved, helping maintain consistent performance under heavy workloads. While most home users rarely encounter U.2 drives, they quietly power systems that require constant reliability, large storage capacity, and continuous operation. What appears less modern at first glance is actually a carefully engineered solution designed for environments where speed, durability, and serviceability are equally important. External SSD. Many people believe that an external SSD is always slower than internal storage simply because it connects through a cable. That idea is only partly true. Modern external SSDs using fast USB or Thunderbolt connections can deliver impressive speeds that are more than enough for video editing, gaming libraries, and large file transfers. Another common misconception is that external drives are only for backups. In reality, many users run applications directly from them or carry entire work projects between different computers. Some creative professionals even edit high-resolution videos without copying files to internal storage first. Of course, connection type still matters, and slower USB ports can reduce performance. Even so, the flexibility of plugging in fast storage whenever needed has made external SSDs one of the most practical storage solutions available. They combine portability, reliability, and solid performance in a package that fits easily into a pocket. Portable Rugged SSD. Unlike ordinary portable drives, a rugged SSD is designed to survive environments that would quickly damage traditional storage devices. Manufacturers reinforce the casing with protective materials that absorb impacts from drops and vibrations while sealing the enclosure against dust and water. Internally, flash memory already has an advantage because there are no spinning disks or moving read heads that can be damaged by sudden movement. Thermal management also plays an important role. Many rugged models include metal housings that help spread heat more evenly, preventing performance drops during long file transfers. Some versions even meet military-grade durability standards after passing repeated tests for shock, temperature changes, and harsh outdoor conditions. Although these drives cost more than standard portable SSDs, their engineering focuses on maintaining consistent performance while protecting valuable data in demanding situations where reliability matters far more than appearance or compact size alone. mSATA SSD. Before the M.2 standard became popular, many compact laptops and small desktop systems relied on mSATA SSDs to provide fast storage without taking much space. For owners of these older devices, upgrading to an mSATA SSD often transformed the user experience. Boot times became much shorter, applications opened faster, and everyday tasks felt smoother than when using a mechanical hard drive. Even today, there are still situations where an mSATA SSD is the right solution. Businesses maintaining older equipment, hobbyists restoring vintage laptops, or industrial systems built around older hardware often depend on this format because newer drives simply do not fit. Although modern computers rarely include mSATA slots anymore, the technology continues to serve an important role wherever compatibility is more valuable than having the latest standard. Its usefulness depends less on age and more on matching the hardware it was designed for. M.2 SSD. Today, this tiny storage drive is mainly associated with compact laptops, handheld gaming systems, and ultra-small computers where every millimeter of space matters. As devices continue becoming thinner and more portable, storage components also need to shrink without sacrificing performance. That trend suggests the importance of the M.2 2230 form factor will continue growing. Future generations of compact computers are likely to rely even more on drives of this size while offering greater capacities than many larger SSDs available today. Improvements in flash memory density could allow several terabytes of storage inside an incredibly small module. At the same time, faster PCI Express standards may increase performance even further without changing the physical dimensions. Although currently considered a specialized form factor, the M.2 2230 SSD may become increasingly common as manufacturers continue designing powerful devices that fit comfortably into smaller and lighter designs. Enterprise SSD. Picture a large data center filled with endless rows of server racks operating day and night. Hidden inside those machines are enterprise SSDs built for continuous operation under workloads far beyond typical personal computers. Unlike consumer drives, they are engineered to handle constant reading and writing while maintaining reliable performance over many years. Many include advanced power loss protection, ensuring that important data remains safe even during unexpected outages. They also use sophisticated error correction and monitoring technologies to detect potential issues before failures occur. Visually, these drives often appear simple and industrial, but they support critical systems behind cloud services, banking networks, online shopping, scientific research, and countless business operations. While most people never see them directly, enterprise SSDs quietly manage enormous amounts of information every second, providing the dependable storage foundation that keeps much of the modern digital world running smoothly.